So good day everybody. Once again, welcome to Nobutin YouTube channel. So in today's class, we want to look into gas laws and its calculations. Now we dropped about 2 videos on this our YouTube channel. Do well to watch them because all those videos we are making, JAMB questions must come out in it. Do you understand? Because JAMB don't omit questions from those topics. Now this is gas laws. So as a student preparing to sit for any exam, you need to know gas laws. You know that gas laws is under physics and also likewise to chemistry. So once you have mastered chemistry, you have also mastered physics using these gas laws. So I'm going to be explaining everything you need to know. All you need to do is to pay maximum attention. So this is the class content of what we will be looking: variation of gas volume with pressure, variation of gas volume with temperature, general gas equation, Dalton's law of partial pressure, law of combining volumes of gases, which is Gay-Lussac Law and Avogadro's law. Then we have ideal gas equation, Grant's law of diffusion, solving of 15 solid questions, JAMB pass questions or JAMB questions. So my name is Nobu, CEO of Nobu Team, and before we start, I will implore you to get either a headset or earphone to avoid anything like distraction. And also, I would advise you to get a calculator because we are going to be calculating along the side. Now let's dive into what we have. But before we dive in, I want us to take note of 3 good important things. Now, once it comes to gas laws, we have pressure, temperature, and volume. And we also have what we call the standard temperature and pressure. Standard temperature and pressure. So in this standard temperature and pressure, its name can be STP, like the abbreviation of it is STP. Now we have something of pressure. We have pressure. Once we talk about pressure at STP, it is what? 760 millimeter mercury. And the unit of pressure, remember that pressure is what? Force over area. Now the unit of pressure can be Pascal, Newton, meter per square. Now, do you know how I derived this? Let me just write it out. Remember that pressure is what? Force over area, right? Pressure is force over area. Then what is the unit of this? Newton. Then what is the unit of area? Meter square. Then we have what? Newton per meter square, or Newton meter this. You understand? So this is the unit of what? Pressure. Now the next one is temperature. Want to talk about temperature at XTP. But before that, take note that the unit of temperature, the main SI unit of temperature is what? Kelvin. So in any question that you are solving and you have it to be in a Celsius state, you have it to convert it back to what? To Kelvin. Now, converting it back to Kelvin, it simply means degrees Celsius, which is the option given to you. Once we solve question, you understand what I'm trying to say. Plus 273. Anything that you are given to convert, then you add it to 273. You have converted it to what? To Kelvin state. Now the next one I want us to take notice that volume is in centimeter cube or in decimeter cube. We are not making use of meter here. So we are not making use of meter. So this is the point I want us to take note before we can be able to look into what we have for today. Now, the next point we have, which is the fresh topic, which is variation of gas law or volume with pressure. Now, once we talk about this pressure, we are talking about Boyle's law. What do I say? We are talking about Boyle's law. Now, what is Boyle's law? Boyle's law states that as a fixed volume mass of a gas is inversely proportional to the pressure at constant temperature. Now, this is what the law is trying to explain. Once V is directly, you understand? V is directly proportional. No, it's not directly, it's inversely proportional to pressure. So this Boyle's law is inversely. Now, once we get to Charles' law, I'm going to give you the mnemonics to remember, to recall it fastly. Now, I want us to remove this sign of proportionality. It's going to be V is equal to K1 over P, then having V is equal to K over P. Now, I want this K to stand on its own. It is going to be K is equal to Vp. So that is why the general equation for Boyle's law is P1 V1 is equal to P2 V2. This is the correct formula for solving for what? Boyle's law. So alright, now let's look into the graphical representation of it. Coming to Boyle's law, we have up to 3 graphical representation of it, and I've seen questions time to time from this graphical representation of it, because that normally set questions from Boyle's law on graph and also on Charles' law. You need to do what? You need to know them. So I'm going to be listing it out. You draw it neatly on your notes. So if you are enjoying this video, do well to do what? To hit the subscribe button and like and share to your friends. So this is the graphical representation of it. So I'm going to be using my blue marker to draw the first one. Then this is it. I have this. So I have a curve here. So this place is V and this place is what? P. So the arrow is moving outward. Now we have the second graph. We have the second graph rather, which is this. The line is moving from the origin. So I have my P and the arrow is moving outward, and I have 1 over V, and this is V, and the arrow is moving outward. This is the second graph. Now the third graph, I have it to be this. Let me draw it here. This, and it is at the terminal. Yes, this is what we call terminal. Once it comes to business, we have terminal velocity. So I don't want to go there. So I have PV, then I have the arrow moving outward, and I have P or V, then the arrow is moving outward. This is the graphical representation of Boyle's law. Now, the next thing we want to look into is the variation of gas volume with temperature. So in Boyle's law, just know that the temperature is constant. The temperature is constant once you come to Boyle's law. Now in Charles' law stated that as a volume of a given mass of a gas or a fixed mass of a gas is directly proportional to the temperature at constant pressure. So in Boyle's law, the temperature is constant. In Charles' law, the pressure is constant. So this is what the law is trying to explain, that V is directly proportional to T. Then V is now equal to K T. So making K to stand on its own, I have it to be K is equal to V over T. That is why we have the general equation for Charles' law to be V1 T1 is equal to V2 over T2. So this is the correct equation, or the general equation for Charles' law. So I want us to take note of the graph. So Charles' law have only one graph, which is this, moving from the origin, and we have V, the arrow is moving outward. Then we have T, the arrow is moving outward. So this is the graphical representation of Charles' law. Now the next one is the general gas equation. Now once we talk about general gas equation is the combination of Charles' law, Boyle's law, and Boyle's law, and Gay-Lussac's pressure law. So I'm going to be explaining this Gay-Lussac's pressure law. Do you understand? So now let's get into what we understand, or what I want to explain about the general gas equation. So now the formula for this general gas equation is P1 V1 over T1 is equal to P2 V2 over T2. So this is the correct equation for general gas equation. So I want us to take note of something. Once the volume is constant in this, imagine I have this to be constant, this to be constant. Remember, I will have something of P1 over T1 is equal to P2 over T2. Now this law is something that we call the pressure law. we call it the pressure law, or we call it the Gay-Lussac pressure law. The Gay-Lussac what? Pressure law. So you take note of this particular point because we are going to be solving questions for this Gay-Lussac pressure law, or we call it the pressure law or the pressure temperature law. So any one that you can remember fastly. Now let's look into the Dalton's law of partial pressure. Dalton's law of partial pressure this law was proposed by John Dalton, the one that we all know. So now the next thing that we want to look into is the Dalton's law of partial pressure. Now coming to Dalton's law of partial pressure, it stated that the total pressure of all gases or the mixture of gases is the sum of all the partial pressure of gases in all. So what is this point trying to explain? So imagine the law. Remember, they say the total pressure, do you understand, is equal to the sum of all the partial pressures in all the gases. So it simply means that once I have P total, let me write it here. P total, which is PT, is equal to P gas plus P water vapor. This WP is what? Water vapor. Or I will have something of P. Let me use here, which is P total is equal to P1 plus P2 plus P3 and so on, depending on the number of the partial pressure given to you. So now we can make use of either of these to solve for any question on Dalton's law of partial pressure, because it depends on the parameters given to you. Now I want us to take note of one important thing, that this P1, P2 are called the individual partial pressure. The individual partial pressure. So we have done the variation of gas laws, variation of gas volume with temperature. This one is variation of gas laws with pressure. So we have done this, we have done this, we have done this, and we have done this. So I cutted the video because I think it was not recording. Yes, it was not recording. So I need to start from the beginning. Now we have the law of combining volume of gases. So we have the Gay-Lussac law and the Avogadro's law. So now let's look into them one by one. Now once we talk about Gay-Lussac's law, remember we have Gay-Lussac's pressure law and we have the Gay-Lussac law of combining volume. Now this law says that when gas reacts, they combine in simple whole number ratio by volume. Now what is this point trying to explain? Imagine I have this. Imagine I have H2 plus O2 to give me what? To give me H2O. So I need to balance this. I have to put 2 here and put 2 here. So how many hydrogen is here? 4. 2 times 2 is what? 4. 2 times 2 is 4. How many oxygen is here? 2. How many oxygen here is 2? So it simply means we have 2:1 and is to what? 2. This is what this law is trying to explain. Now Avogadro's law now puts in place the same, both of them are still the same thing, but what Avogadro's law did was this, because Gay-Lussac's law is already dead. Yes, he died. Then Avogadro's now picked the law and made an hypothesis on it. So he now said that equal number of volume under the same condition of temperature and pressure have the same number of molecules. Equal number of volumes under the same conditions of temperature and pressure have the same number of what? Volume. So this is what this Avogadro's law of combining volume stated. Now let's look into ideal gas equation. So you need to pay maximum attention here. Yes. Now this ideal gas equation is the combination of Charles' law, Boyle's law, and Avogadro's law. Remember that general gas equation is the combination of Boyle's law, Charles' law, and what? Pressure law, which is this Gay-Lussac's law, pressure law. But in this ideal gas equation, it is the combination of Charles' law, Boyle's law, and Avogadro's law. Now, I want us to get the formula for this. You understand? Yes, let's get the formula for this. We have the ideal gas equation to be PV is equal to nRT. Yes, yes, that is it, because we have the number of moles. Then this is the universal gas constant, temperature, pressure, and volume. This is from the Boyle's law and Charles' law. This is from the Avogadro's law. You can see it is the combination of Charles' law, Boyle's law, and Avogadro's law. Now, any gas that obeys this law is said to be what? An ideal or perfect. Any law that obeys this equation is either an ideal or what? A perfect gas. So this point must be noted. And I want us to get the constant. Remember, this is called the universal gas constant. Yes, I want us to get this particular universal constant by solving for it, so you can understand how it is being derived. So I want us to take note that once it comes to this ideal gas equation, we have that pressure must be in atm. Yes, that one is a very vital point you need to take note. Volume must be in dm, not in centimeter. Then we need to solve it and get the unit. Temperature must be in Kelvin, and this n must be in moles. Now let's solve to get the constant of this. So we have it to be, my P is 180. Yes, but before we solve, let's make this R subject of formula. I have R is now equal to PD over NT. So I've made this the subject of formula. I have my P, which is 1. Then at XTP, yes, at XTP, volume is 22.4 dm cube. 22.4 dm cube. And I have the number of moles, and also I have the temperature. Number of moles is 1. I have the temperature to be what? Times 273. You understand? So make sure let's punch this on calculator to get the answer to this. So let me get my calculator. I have it to be 22.4 divided by 27.3. So the constant of R is now equal to 0.0821. Now let's get the unit. Let's get the unit of it. This is what? Pressure, which is atm. This is dm cube. Then over mole. And this is what? Kelvin. Yes, this is Kelvin. So this is the unit of it. So I might decide to write it, remove this and put what? This part. So both of them are what? Are still the same thing. This is the constant of this universal gas constant. Yes. So now let's look into the Graham's law of diffusion. Then we solve questions. Now, Graham's law of diffusion is being done on a gas. Yes, this law is related to gas. Anything gas. So now once we define this, we get the formula to it. Now, this law stated that the rate of diffusion of a gas is inversely proportional to the square root of the vapor density, provided that the pressure and temperature is constant. Pressure and temperature is constant in Graham's law of diffusion. Now, this is what the law stated. It stated that the rate of diffusion is inversely proportional to the square root. Is inversely proportional to the square root, and we have it to be R1 is equal to R2, then to the square root of what? Then M1, or we call it, no, not M1, M2, or we call it the D2. This M2 is either the mass, D2 is the density, the molar mass, the density, and M1 over D1. So anyone can go. It depends on the parameters given to you in the question. So I want us to solve some real exam questions that we see, and you film normally, because these things are very, very easy. Do you understand? Now let's solve questions under this. Make sure that you have mastered everything we have done in Boyle's law, Charles' law, general gas law, Dalton's law of partial pressure, law of combining volume, ideal gas equation, Graham's law of diffusion, solving of, and this, sorry, this is the next thing we want to look into, solving of 15 solid JAMB questions. Now let's solve questions. Make sure you get your pen, your biro, and your calculator, because you'll be calculating along the side. Alright, now let's solve questions under what we have done, and make sure you pay maximum attention. Now, question 1, the question will appear on your screen. So question 1 says the ratio of the initial to the final pressure of a given mass of gas is 1:1.5. Then calculate the final volume of the gas if the initial volume was 300 centimeter cube at the same temperature. Now once you look at this question, once they say at the same temperature, at constant temperature, they are simply talking about Boyle's law. So you don't need to bother yourself. Now you just recall rather the formula for Boyle's law, which is P1 V1 is equal to P2 V2. So in the question, they said that the pressure, which is the initial and the final. So if okay, now I want us to take note of this, that P1 is the initial, then V1, anything 1 first is the initial, then 2 is the what? Is the final. You understand? So I want us to take note of that point. Now, coming to this question, we have it that our first pressure is 1, which is 1 multiplied by, then the first volume is what? 300 is now equal to 1.5 multiplied by V2. So we are looking for V2 according to the question. So we have it to be V2 is equal to 300 divided by 1.5. So once you divide this, it will give you something roughly around 200 centimeter cube. Let me do the calculation here so I will confirm. 300 divided by 1.5. Yes, 200 centimeter cube. So in this particular question, once you hear constant, even though they gave you that parameters, you don't need to solve it. You understand? So we'll be solving questions and you'll be mastering everything. So all you need to do is to pay maximum attention. And if you are enjoying this video, make sure that you hit the subscribe button, share to your friends so they can also benefit. So now let's look into question 2. So now question 2 says the pressure on 100 centimeter cube of oxygen gas at 35 degrees Celsius is 70 millimeter mercury. Then what should be the volume of the gas if the pressure is increased to 100 millimeter mercury without changing the temperature? Now this question is very, very crazy. So I think I remember something. This Charles law, Boyle's law, and Boyle's law. I want us to take note of this, that once there is an increase in pressure, there is a decrease in volume, and the vice versa of it, which is an increase in pressure will lead to a decrease rather in volume. So an increase in volume leads to a decrease in pressure. But in Charles law, they are both increasing. Volume increase, pressure increase, volume increase. Now this question is very, very tricky. They gave you temperature, and they're also telling you that the temperature is constant, which is it is not changing. So this is the question that you don't need to rush. Do you understand? You don't need to rush this kind of question. Now they say without changing the temperature. The simply means I don't have any business with the temperature. Do you understand? Even though you have the values, don't let them confuse you. Do you understand? Just make use of a little common sense. So coming to this, we are going to be using what formula? Let's read the question again. We have the pressure on 100 centimeter cube of oxygen gas at 35 degrees Celsius is 70 milliliter mercury. What would be the volume of the gas if the pressure is increased to 1000 millimeter mercury without changing the temperature? It simply means we are making use of the Boyle's law. Do you understand? We are not making use of the general gas law, because they say that in the question the temperature is not changing, it is constant. So we have it to be our first volume is 100, which is 750 multiplied by 100 is equal to, then we are asked to be, what is the volume, the final volume, which is 1000 millimeter mercury multiplied by V2. So we have this to be 750,000 is equal to 1000. So we have V2 is equal to 750 is equal to 1000. So once you divide this, let's divide. We have it to be 750,000 divided by 1000. So sorry, I made a mistake. Yes, this should be 75,000. This should be 75,000. So make sure you correct it in your notes. 75,000. Now let's substitute again. 75,000 divided by 1000. We have it to be 750 centimeter cube. So option what is correct? We have it to be option C is correct. So now once they say constant, even though you have the volume, even though you have the value, sorry, just fashion that thing. You understand? Fashion those values. They want to confuse you. You understand? You can use pressure law to solve for this and still arrive. No, Avogadro law to solve for this and still arrive at the answer, but not the correct answer. You understand? That is why I said in the previous video, you know the formula, but you not arrive at the answer. So that is why you need to read question very well before you solve. Now let's look into question 3. Let's look into question 3. And in this question 3, I don't think I will solve it. You need to solve it and give it to me in the comment box. They said, which of the gas laws does the above graph illustrate? So I said this. So which of the gas laws does the above graph illustrate? So I don't need to explain this. Do you understand? You need to give it to me in the comment box. Now let's look into question 4. Now question 4 says a gas sample with an initial volume of 3.25 dm is heated and allowed to expand to 9.7 dm cube at absolute pressure. What is the ratio of the final absolute temperature to the initial absolute temperature? Now coming to this question, we are asked to get both the final and the initial temperature. Both the volume is given. Do you understand? So in this question, it is Charles' law because we have the parameters to be volume and temperature, but we are asked to get the ratio of the final and the initial. So we have Charles' law to be V1 over T1 is equal to V2 over T2. I hope you know that you can rearrange this. Yes, you can rearrange this particular formula now, since we are asked to get the initial and the final of this. Now once we are rearranging this, you can have it to be T1 over T2 is equal to V2 over T1. I hope you know you can rearrange this. According to the question, it says that the ratio. Now we have this, our final volume to be 9.75, and we have the initial to be what? To be 3.25. So if you are still not understanding what I did here, we are asked to get the ratio of it. So this is a basic mathematics. Do you understand? So we have this and we have this. So we are asked to get the initial of this, the initial of the temperature. Once I make these people the subject of formula, I need to make this the subject of formula. I'll have, yes, once I make this the subject of formula, I'll have this. This is V. Once I make this the subject of formula, I'll have this. So once we solve Gauss law of diffusion, you understand what I'm trying to say here. Do you understand? Now once you divide this into this is 3 and over 1. So it simply means it is what? 3:1. 3:1. So option A is correct. Now let's look into question 5. Let's look into question 5. So I hope you understand what I'm doing here. So if you are a bit confused, you move the video back, you pay maximum attention to it, because that is a full video lecture that I'm about to drop. So all you have to do is, if you don't seem to understand what I'm doing, you drop what you are not understanding in the comment box. I will be there to do what to answer. So question 5, which of these, or which is the temperature of a gas, of a given mass of a gas, which is initially at 0 degrees Celsius and 9 atm, if the pressure is reduced to 3 atm at constant volume. So we have it to be 0 degrees Celsius. And remember when I said something about anything XTP and temperature, remember I said earlier that we are not solving with temperature, we are solving with a Kelvin state. Once you are given anything in degrees Celsius or degrees centigrade, you convert it back to what? To temperature, to Kelvin state rather. So we have it that, but before we convert, what formula are we using here? They say that the volume is constant. So I explained something about it. Once volume is constant, we make use of the what? The pressure law, or we call it the Gay-Lussac pressure law. So we have it to be P1 over T1 is equal to P2 over T2. So this is the formula we'll be using rather. So our P1 is what? Is 9, and our T1 is what? 0 degrees Celsius. And converted to degrees centigrade, it simply means K is equal to T, or degrees Celsius, plus 273. So our degrees Celsius is 0 plus this 273 will give us 273. So we have it 273 is equal to, our P2 is what? 3, and we are looking for X, which is the T2. Now making this object of formula, I'll have 3 multiplied by 273 divided by 9. So let's punch our calculator to know the correct answer to this. We have 3 multiplied by 273, then divided by 9. So I have it to be 91 Kelvin. 91 Kelvin. So let's look into the correct option to know which one is correct. Or rather, let's look into the option to know which one is correct. So option A is correct. Now, some of you might be asking me, why is it not in degree Celsius when I finish solving? Because I've made have done a conversion here, which is this. Imagine I use that 0 points to solve. Once I finish solving, I'll need to convert it back to this. You understand? Now let's look into, we solved question 5. Let's look into question 6. So make sure you do what? You subscribe to this YouTube channel for more videos like this. So question 6. A sample of a gas exerts a pressure of 8.2 atm when conified in a 2.9 dmq container at 20 degrees Celsius. The number of moles of gas in the sample is what? So this question is referring to an ideal gas law. So remember when I said that when you are solving questions in this ideal gas law, you make sure that your pressure is in atm, then your volume should be in dm, then your temperature should be in Kelvin state. Remember when I said so? Now let's solve and get the correct answer to this question. So we are asked to get the number of moles. We are asked to solve for the number of moles. So I have it to be PV is equal to nRT. Then is now equal to N is now equal to this. N is now equal to PV over RT. So I have my P to be 8.2 multiplied by V, which is 2.93 divided by R. My R is, which is the universal gas constant, 0.082 multiplied by the temperature, which is 273 plus 20 degrees is going to give me 293. So let's add up to get the number of moles. Let's add up to get the number of moles. Make sure you are punching it on your calculator. So we have 8.2 multiplied by 2.93, then divided by 0.082 multiplied by 293. So wait, let me punch it again. This is how to do it. So you first and add this up. Once you multiply this, you bring out the answer. Multiply this and then divide. Don't go and punch it once. Because once you punch it once, calculator will not give you the right answer. That is the mistake I did here now. So I have 8.2 multiplied by 2.93. I have this. This is my value. I think this ring light is just like it's disturbing. This my light is disturbing. So 0.26. This is the numerator. Then let's solve the denominator. 0.082 multiplied by 2.93. Yes, not 2.93, 293. I have it to be divided by 24.026. Now, once this divide, you have it to do what? 1. You have it to do what? 1. So it simply means that the number of moles is 1. The number of moles is what? Is 1. Now, let's solve questions. Let's solve more questions. We have solved up to 6 questions. Now, let's solve question 7. Now, question 7 says, a gas occupies a volume of 30 dm cube at STP. So make sure you do what? You master that STP that I said earlier, and make sure that you read questions carefully, because once you see STP, you think it's just a normal way. Now, this STP simply means standard temperature and what? Pressure. Standard temperature and pressure. So they ask what volume will it occupied at 9 degrees Celsius and 38 millimeter mercury. So this question is based on what law? It's based on general gas law, because they state that at STP, and we also have two temperatures and 1 volume. We are looking for the final volume. So I'm going to be making use of this formula, which is, let me wipe this up, which is P1 V1 equals to T1 over T1. Then we have P2 V2 over T2. So now, my P1 is what? Remember, they said P1 is at XTP. So P1 is 760 multiplied by my V2 is what? 30 divided by my T2. My T1 is at STP, which is 273. Then is equal to my P2 is what? 380. Then multiply by V, which is the second one we are looking for. Then I have my final temperature to be 91 degrees Celsius. So I need to convert it back to what? To Kelvin stage. It simply means 273 plus 91, which is 364. Now let's solve and get the V2. I have V2 is now equal to what? V2, I'm making V2 the subject of formula, which is 760 multiplied by 30, then multiplied by 364 divided by this 273 multiplied by 380. Now let's punch. We have 760 multiplied by 30 multiplied by 364. Remember, push it one by one. So the first one I have is 8299, then 200. Now let me punch this and get the final answer. I have 273 multiplied by 380. I have it to be 103,740. So now let's punch them. 8299 200 divided by 103,740. So I have it to be what? 80 centimeter cube. So this is the V2 and we have gotten the answer. Now let's look into the question to know which one is correct. We have option D to be correct. So it is in DM. So let's move into the next one, which is question 8. So now this question 8 is another question based on another law. So we have this to be the densities of two gas X and Y are 0.5 dm cube and 2.0 gram per dm cube. Then respectively, what is the rate of diffusion of X relative to Y? So we are asked to get the diffusion of X relative to Y. Now let's solve. We have the densities. Remember that in this particular law, in this particular Graham's law, we have the formula to be this. Actually, let me use my blue marker because this part is already filled up. Let me use my blue marker. So I have the formula to be this. This is the formula. R1 over R2 is now equal to D2 over D1, or we call it the molar mass. Remember what I said earlier, then square root. So we are looking for the rate of diffusion. Now my D2 is what? My D2 is 2, which is equal to the square root of 2 over 0.5. So what am I going to do here? 2 divided by 0.5 should be 4. Then the square root of this 4 is what? 2. So it simply means that the rate of diffusion relative to X and Y is 2. So option C is correct. Now let's look into question 9. So I'm going to be solving up to 11 or 10 questions. Then you solve the remaining for me. Now in this question 9 says hydrogen diffuses through a porous plug we have A at the same rate as oxygen, at a slower rate than oxygen, then twice as fast as oxygen, thrice times as fast as oxygen, 4 times as fast as oxygen. So what is this point trying to explain? Now let's solve together, but before we solve, let me wipe out this so we can have a space for this. So I'm going to pause the video. So I've wiped the board so we can have enough space to solve. So this question 9, it says hydrogen diffuses through a porous plug So I've read out the option. So now let's solve. So in this question, if you look at the option, they're talking about oxygen. Now let's remember this formula. Do you understand? Let's remember this. This is the formula when I was explaining that this can either be density or the molar mass. So we are asked to get the rate of the diffusion of how hydrogen will diffuse in the porous plug. So my M2 here is what? Now looking at this question, my M1 is hydrogen as written in the question, but in the option it is what? Oxygen as the second molar mass. So what is the molar mass of this particular oxygen? Now the molar mass of oxygen is 32. Take note of it. Now the molar mass of oxygen is 32. And I want us to take note that once you are solving anything on Graham's law of diffusion, you need to master the molar mass, the relative molar mass of it, the relative molar mass of it. Now which is 32. Then what is the relative molar mass of hydrogen? The relative molar mass of hydrogen is 2. Then in a squared form, divided. Then 32 divided by this will give me 16. Then the square root of 16 is what? 4. So it simply means that hydrogen will diffuse 4 times as fast as oxygen. So option E is correct. Now let's look into question 10. We have solved up to 9 questions now. So remember 15 solid questions. So I'm going to be solving up to 11 as I said earlier. Then you solve the remaining one for me. Then this question 10 says if the rate of diffusion of oxygen gas is taken as 1, what will be the rate of diffusion of methane whose relative molar mass is 16? Then we are going to still be making use of this. Now the rate of diffusion of the oxygen is 1 divided by, we are asked to get the rate of diffusion of the methane. I represent it as 2, R2, then is equal to M2 is what? They say it is 16, square root of 16 divided by M1. What is the relative molecular mass of this oxygen? Which is relative molecular mass of oxygen is 32. So this is what I'm trying to avoid, because I want us to take note of something here. Do you understand? Because 32, yes, O2 is, it is the atomic inertia. So I have this, which is 1 over R2 is equal to 1 over, then 16 into this will give me 2. Then we also have our square root. So this particular thing is a quite confusing thing that you need to know. Do you understand? But I will implore you to take them step by step. Do you understand? I will implore you to take it step by step to avoid anything like what? Mistake. Now, this is what you are going to do. Let me get my calculator. So I want us to get the square root of 1. Remember that this square root is covering everything in this particular notation that is here. So square root of 1 is 1. Square root of 1 is 1. Then the square root of 2 is what? 1.4. So I've gotten the square root. So I'm just giving you the basic step you need to know. You understand? To avoid anything like mistake or confusion in this. So we have it to be 1 over 1.4. So 1.4. So I have it to be 1 over R2 is equal to 1 over 1.4. So making R2 the subject of formula, I have R2 is equal to 1.4 multiplied by 1 divided by 1, which is what? 1.4. So the rate of diffusion of the methane is 1.4. So option C is what? Correct. You can see how I take it step by step to give you the insight of how to solve. So if this particular root is disturbing you, because normally I normally make use of this method to avoid anything like confusion or solving nonsense. Do you understand? Now let's solve question 11. Now this question 11, I think I've not explained it, but I'm going to explain it once we solve questions on it. So it said, which of the following gases will diffuse faster when passed through a porous plug? We have 11 is equal to, not 11, H is equal to 1 hydrogen, carbon is equal to 12, nitrogen is equal to 14, oxygen is equal to 16. So I want us to pay maximum attention here. They say, which of the following gases will diffuse? We have A, propane, oxygen, methane, and ammonia. So I'm going to be solving for the relative molecular mass of each of this particular thing. So let's start with propane. So propane is an organic compound. Propane is an organic compound with a general molecular formula of what? C2H6. C2H6. So propane, which is P, C2H6 is now equal to, carbon is what? 12, which is 12 times 2 plus 6 multiplied by 1 is equal to 12 times 2 is what? 20. Excuse me. 12 times 2 is what? 24. 24 plus 6 is equal to 30. So we have solved for propane. Now the next one is oxygen. Oxygen is the atomic inertia, which is 16. Which is 16 multiplied by what? 2, which is 32. So make sure you do what? You know this particular thing. Avoid that mistake that I made earlier. The relative molecular mass of oxygen is what? Is 32, which is 16 times 2. If normal relative molecular mass is 16, do you understand? Since it is the atomic inertia, we multiply it by 2. So let's normalize this mistake that I made. Now let's look into oxygen, which is 32 gram per dm cube. Now we have methane. Did I make any mistake here? No. So we have methane. Methane is what? We have methane, which is CH4. CH4 is what? My 12 plus 4 is equal to 16. So I've gotten the relative molecular mass of this gram per dm cube, then gram per dm cube. So I want to show you guys something concerning this particular thing that I want to do. That is why I'm taking my time to get the relative molecular mass of each option given to us. Now we have ammonia. Ammonia is NH3. Our nitrogen here is what? 14 plus 3, which is 17 gram per dm cube. And we are asked to get the gas that will diffuse fastest when passed through a porous spot. Now take note of this. Once you are asked the gas that will diffuse fast in a porous spot, once it comes to Grams law of diffusion, just know that the one with the highest molar mass will diffuse faster. You understand? The one with the lowest lower mass, molecular mass, will diffuse what? Will diffuse lower. You understand? Yes, the fastest we have the highest value, then the slower we have what? We have the lowest, we have the slowest diffusion rather. You understand? So the highest the highest relative molecular mass will diffuse fastest. Now the slowest we have the lowest value. You understand? Now looking at this option, which one has the highest value in terms of molar mass? So we have it to be what? To be oxygen. So it simply means that oxygen will diffuse what? Fast than each of these, followed by this, then followed by this and this. So this methane will be the lowest to diffuse. This is what I'm trying to explain. Now we are question 11. So let me solve more questions. Do I need to solve more questions again? Yes, let's solve more questions. Then you give me the rest in the comment box. So we have solved question 11. Yes, you have solved question 11. So I don't need to solve again. I'll give you the rest as an assignment. I'll give you the rest as an assignment, which is the remaining 4. You solve it and give it to me in the comment box. So I hope you all enjoyed this particular video lecture for today. So make sure you subscribe and wait for another more beautiful content like this. So if you want to know more about Noble Team is an online educational platform that gives or provides quality lectures for science students only. So if you want to know more about us, make sure you click the link in the description of this video, and I will be waiting to see you on the next video. Bye.